2025, a Boeing B-52 Stratojet lifts off from Minot Air Force Base in North Dakota. 8 roaring jet engines power it skyward. Swept wings slice through the air. This bomber has been flying since 1952, a staggering 73 years of continuous service. It's projected to fly until 2050, almost a century. But take a close look at the design, the swept wings, the fuselage, the engine nacelles. This design isn't American, it's German. From 1945, July 30th, 1943. Arado Aircraft Works, Germany. A sleek aircraft takes to the skies for the first time. The R-234 Blitz, 2 Jumo Aero 4 jet engines. Aviation would never be the same. This is the world's first operational jet bomber. Not just a prototype, but an actual combat bomber, faster than any Allied aircraft of its time, virtually untouchable. The problem? By 1943, Germany is already losing the war. Only 210 would ever be built. But the concept is proven. May 1945. Germany surrenders. But the war for technology has only just begun. The Army Air Force's von Karman mission inspects a secret German aviation laboratory near Braunschweig. The team includes George S. Schairer, head of the technical staff at Boeing. He had heard of R.T. Jones's controversial swept-wing theory at Langley, but when he sees German models of swept-wing aircraft, extensive supersonic wind tunnel data, the concept is decisively confirmed. Schairer sends a telegram to his office in Seattle. 5 words: stop the bomber design, change the wing design. This telegram changes the history of aviation forever. The technological lineage is undeniable. The R-234 proves the jet bomber concept in 1943. German wind tunnel research provides swept-wing data in 1945. Boeing builds the B-47 using German data in 1947. The B-52 follows in 1952 using the same concept. In 2025, the B-52 is still flying. German design. American production, global dominance. Today, I will show you the documented history. The R-234 Blitz wasn't the first jet aircraft. The Messerschmitt Me-262 flew earlier, but the Me-262 was a fighter. The R-234 was a bomber. The difference is critical. A jet fighter proves that jet engines work. A jet bomber proves that jet engines work for strategic warfare. Long-range flight, bomb payload, high-speed penetration of enemy defenses. The R-234 was the first to prove this. The technical specifications were impressive for 1943. Top speed, 457 miles per hour. Range, 1,013 miles. Service ceiling, 33,000 feet. Bomb load, 3,300 pounds. 2 Jumo 04 jet engines, each producing 2,000 pounds of thrust. Pressurized cabin for the pilot. The design was elegant. Sleek fuselage, shoulder-mounted straight wings. Engines in nacelles under the wings. Everything optimized for speed and range. The first deployment came in September 1944. Reconnaissance missions over Great Britain and France. The R-234 was so fast that British Spitfires couldn't intercept it. Even if they spotted it, it could simply outrun them. The Allies were frustrated. They had no defense against a bomber they couldn't catch. This was the future of warfare, and Germany had achieved it first. But Germany in 1944 had no resources for mass production. The R-234 required rare materials, specialized manufacturing, experienced pilots. Everything was in short supply. Of the 210 R-234s built, only about 150 reached operational units. Most were destroyed in Allied bombing raids on German airfields, not in air combat, on the ground, because Germany didn't have enough fuel to fly them, or enough pilots to fly them, or enough airfields to keep them safe. The irony is bitter. Germany developed the world's most advanced bomber, but couldn't use it. Allied engineers saw it, studied it, immediately recognized the potential, If Germany had had this bomber 2 years earlier, if it had the resources for mass production, the Battle of Britain might have turned out differently. But 1944 was too late. The technology was there, the industrial capacity was not. May 1945, Germany surrenders. The Allies storm German factories, air bases, research laboratories. They find captured R-234 bombers, some still airworthy. These are immediately shipped to America and Great Britain for analysis, for testing, for reverse engineering. Every detail is documented. Engine design, aerodynamics, materials, production methods, everything. The National Air and Space Museum in Washington, D.C. has an R-234 today. It is the only known surviving example, painstakingly restored. It hangs in the Udvar Hazy Center. Visitors can see it. The elegance of the design, the advanced technology. But what they can't see are the documents, the declassified reports, the technical analyses that show how this one aircraft influenced the future of aviation. But the AR-234 itself wasn't what Boeing was most interested in. It was the research data, the wind tunnel studies, the aerodynamic tests. The Germans had spent years researching supersonic flight, swept wings, delta wings, area rule, boundary layer control. Each of these concepts was tested in German wind tunnels, documented, refined. May 1945, George S. Schairer enters the German Aviation Research Laboratory near Brunswick. He isn't alone. The von Karman mission has several leading American aeronautical engineers. But Schairer is the head of the technical staff at Boeing. What he sees here will directly influence Boeing bomber designs, and he sees something remarkable. Models of aircraft with swept wings. Not just concept drawings, actual tested models with data, years of wind tunnel tests, measurements at various speeds, various angles, various configurations. The Germans had done it all. They had proven that swept wings drastically reduced drag at high speeds. They had calculated the optimal angle, around 35 degrees. They had even developed production methods. Schairer immediately understands the implications. Boeing is currently designing a new bomber. The Model 432, with straight wings, conventional design, but if swept wings work, if the German data is accurate, then the Model 432 is obsolete before it even flies. He must act quickly. He sends a telegram to Boeing in Seattle. The content is concise: stop the bomber design, change the wing design to swept wings based on German wind tunnel data. This telegram is now declassified. It's in the Boeing archives. 5 words that changed the history of aviation forever. Boeing engineers receive the telegram. They are skeptical. Swept wings. That sounds like science fiction. But Schairer is the head of the technical staff. He has seen the German data. If he says it works, then it probably works. So, they stop the design of the Model 432. They start from scratch, with swept wings. The engineer Vic Ganser suggests an optimal sweep angle of about 35 degrees. Exactly what the German data showed. Boeing Aeronautics modify the Model 432 with swept wings and empennage to produce the Model 448. This is presented to the USAAF in September 1945, just 4 months after Schairer's telegram. The transformation is remarkable, from conventional straight wing to revolutionary swept wing, all based on German research data. The USAAF is impressed. The Model 448 promises performance far beyond anything they had anticipated. Higher speed, greater range, better high-speed performance. All thanks to German swept wings research, Boeing receives a contract to develop what will become the B-47 Stratojet. But there was a problem. Boeing had never built swept wings before. The manufacturing methods were unknown. The structural requirements were different. The aerodynamic properties were novel. So, they returned to the German data, not just the wind tunnel studies. Also, production drawings, structural analyses, test reports. The Germans had documented everything. Boeing used it all. The B-47 prototype flew on December 17, 1947, exactly 44 years after the Wright brothers' first flight. The symbolism was not accidental. This was another revolutionary moment in aviation, the first American bomber with swept wings. And it was spectacular. Top speed 600 miles per hour. Almost double the B-29 Superfortress from World War II. Service ceiling 40,000 feet. Range 4,000 miles. Bomb load 25,000 pounds. This wasn't just an improvement, this was a quantum leap, and all thanks to German swept wings research. The technical lineage is clear. R-234 proves the jet bomber concept, July 1943. German wind tunnel tests swept wings, 1943 to 1945. Schairer sees German data, May 1945. Boeing stops Model 432, designs Model 448 with swept wings, B-47 prototype flies, December 1947. Production begins 1950. Every step is documented. Every decision is based on German research data, but the B-47 was just the beginning. Boeing used the same swept wings concept for larger bombers. In 1948, work begins on a new strategic bomber, initially designed with straight wings and 6 turboprop engines. But the engineers remember the B-47, the German data, the success of the swept wings. Why not use the same concept for a larger bomber? The design evolves, from straight wings to swept wings, from turboprops to jet engines, from 6 engines to 8. The result is the B-52 prototype. It flies in April 1952. Just 5 years after the B-47, the development is rapid because the concept is already proven. The swept wings work. The German data was correct. The B-52 Stratofortress enters service in 1955. It's massive. 164 feet wingspan, 159 feet long, 8 Pratt & Whitney J-47 jet engines, top speed 625 miles per hour. Range 700 miles without aerial refueling, bomb load 70,000 pounds. This is not a tactical bomber like the R-234. This is a strategic bomber, designed to deliver nuclear weapons over intercontinental distances. But look at the design. Swept wings, 35-degree sweep, engines in pods under the wings, sleek fuselage. Every one of these elements was influenced by German research data. Boeing didn't copy it. They refined it, improved it, adapted it for a much larger bomber. But the basic principles, German 1945, 2025, the B-52 is still flying, 73 years after its first flight. It has been modernized, new engines, new avionics, new weapons, but the basic design unchanged. Swept wings, 35 degrees, German concept from 1945, American production since 1952, global dominance to this day. The numbers are remarkable. 744 B-47 Stratojets produced, 742 B-52 Stratofortress produced. Together, almost 1,500 bombers, each with swept wings based on German research data. The economic impact is hard to quantify, but think about it. The B-52 costs about $84 million per unit today, modernized version. At 742 units produced, that's over $62 billion, just for the B-52. Without the B-47, without the civilian aircraft that use the same concept, because swept wings technology wasn't limited to bombers. Boeing's fundamental design features, cylindrical fuselage, swept wings, and engines in pods, were not only adopted by tankers and the next generation of bombers, but also by most of the world's commercial jet transport aircraft. Boeing 707, Boeing 737, Boeing 747, Boeing 777, Boeing 787, all-use swept wings. All are based on the concept that George Schairer saw in a German laboratory in May 1945. The global aviation industry is worth $838 billion today. Boeing alone has annual revenue of over $66 billion. Airbus, their European competitor, over €65 billion. Both companies build aircraft with swept wings. Both are based on German research data from 1945. The economic impact of a single line of research is astronomical. But let's get back to the military lineage. The B-52 wasn't the last American bomber. The B-1B Lancer came in 1986. Variable swept wings. Can sweep from 15 degrees for takeoff and landing to 67. 8 degrees for high-speed flight, but the concept, still swept wings, still based on the principle that the Germans tested in wind tunnels. The B-2 Spirit came in 1997. Flying wing design, stealth technology, radically different from the B-52. But look closely. The leading edge, swept, about 33 degrees. Why? Because sweep reduces radar cross-section and improves high-speed performance. The physics haven't changed. The German data was correct. So, even stealth bombers use sweep. 2025. The USAF operates all three, B-52, B-1B, B-2. Together, they form the nuclear triad, the ability to conduct strategic bombing raids. Each uses swept wings. Each is based on principles developed by German researchers in the 1940s. The technological lineage is unbroken from 1945 to today. But there was another lineage, one that's less well known but just as vital. The Soviet lineage, because Germany capitulated in May 1945. The Soviet Union occupied East Germany, and Soviet engineers had access to the same research labs, the same wind tunnels, the same data. In fact, the Soviets took more German researchers than the Americans. Operation Aviation in October 1946 deported thousands of German scientists and engineers to Russia, including many from aeronautical research. These men brought their knowledge with them, their data, their experience. The result? The Tupolev Tu-16 Badger, 1952. Swept wings, 35 degrees, engines in nacelles beneath the wings, a slightly different configuration than Boeing, but the same principle. Top speed, 652 miles per hour. Range, 4,474 miles. This was the Soviet answer to the B-47, and it was based on the same German research data. Then the Tu-95 Bear, 1952, turboprop strategic bomber, swept wings, enormously successful, still flying in 2025. Like the B-52, both bombers, both with swept wings, both from 1952. Both based on German research from 1945, both still flying 73 years later. The parallels are not coincidental. The global impact is clear. American bombers, Soviet bombers, British bombers like the Vulcan and Victor, French bombers like the Mirage 4, all developed in the 1950s, all with swept wings, all based on German research data captured in 1945. A single research lineage influenced the entire global bomber fleet for 80 years. And now the critical question: who were these German researchers? Who developed the swept wings theory? The names are less well known than Werner von Braun or Konrad Zuse, but their impact was just as great. Adolf Bussmann, German aeronautical engineer, presented the swept wings theory at the Volta Conference in Rome, 1935. His mathematical analysis showed that sweep reduces wave drag at high speeds. The theory was initially ignored. No one was flying at supersonic speeds back then. It seemed academic. But German researchers tested it anyway, in wind tunnels, systematically. By 1945, the Germans had extensive data. Different sweep angles, different speeds, different airfoil profiles, all documented, all tested, all ready for application. And then the war ended. This data was captured by America, by the Soviet Union, by Great Britain, and disseminated. Bussmann himself went to America as part of Operation Paperclip. He worked at NACA, the predecessor to NASA in Langley, where he continued to research high-speed aerodynamics. His work influenced not only bombers, but also rockets, spacecraft, supersonic transports. His legacy is everywhere in modern aviation. But many other German researchers were taken to the Soviet Union against their will. They worked in Soviet design bureaus, developed Soviet aircraft, rocket systems, and then, in the 1950s, most were sent back to Germany. Their work was done. The Soviets had learned what they needed. The German researchers returned to a divided country, East or West Germany, depending on where they originally came from. The human dimension of this story is rarely told. German engineers who worked for Germany during the war, then for America or the Soviet Union after the war, not always voluntarily. Their research was used to build bombers that could have destroyed their homeland. That's the tragedy of scientific work in wartime. Knowledge has no nationality, but its application can be turned against its creators. Nevertheless, the technical achievement is undeniable. The German researchers developed swept wings technology to the point of practical application. They tested it thoroughly. They documented everything. And when the war ended, this knowledge became the foundation of global jet aviation, not just bombers, also airliners, fighters. Everything. Today, 2025, thousands of aircraft fly with swept wings. The Boeing 737, the most produced airliner in history, over 11,000 built. Swept wings, 25 degrees of sweep, based on the same principle that Bussmann presented in 1935 and German wind tunnels confirmed by 1945. Every 737 flight is a testament to German research. Airbus A320, over 10,000 built, swept wings, 25 degrees. Boeing 777, over 1,700 built, swept wings, 31.6 degrees. Boeing 787, over 1,100 built, swept wings, 32.2 degrees. The list goes on. Every modern airliner uses sweep. Everyone is based on the physics that German researchers developed, and military aircraft, F-15 Eagle, swept wings, F-16 Fighting Falcon, swept wings, Eurofighter Typhoon, Canard Delta, but the main wings are swept, Rafale, swept, J-20, swept, Su-57, swept. Every modern fighter aircraft uses sweep. The physics is universal. The German researchers discovered it. The world uses it. The economic impact is hard to overstate. The global aviation industry employs millions, moves billions of passengers annually, delivers trillions of dollars in goods, and it's all based on aircraft with swept wings. The research lineage that began with Bussmann in 1935 was developed in German wind tunnels by 1945 and was captured by Schairer in May 1945, is the foundation of this industry. But let's return to the original question. Did the Americans steal for the B-47? The answer is nuanced. They captured research data from a defeated nation. That was standard at the time. Intellectual reparations, spoils of war, call it what you will, but they never paid royalties. They rarely acknowledged the German researchers. The Schairer telegram doesn't mention Bussmann. Boeing technical reports rarely cite German sources, but the data is clear. Without German wind tunnel research, Boeing might have eventually developed swept wings, but not in 1947, maybe 1950, maybe 1955. The German data accelerated the development by years, possibly by a decade. In a race with the Soviet Union, that was crucial. And the Soviet Union, and they took German researchers, forced them to work, then sent them home when they were done. Is that better than capturing data? Or worse? The ethics of the post-war era were complicated. Each nation took what they could. Germany had started the war. Germany had lost. The victors divided the technology. But the German researchers themselves paid the price. Busemann went to America, worked at NACA, died in Colorado in 1986. His name is known to aeronautical engineers, but to the general public, unknown. How many people flying in a Boeing 737 know that the swept wings design is based on Busemann's work? Almost nobody. That's the fate of many inventors. The technology survives. The name fades. Swept wings are everywhere, but Busemann is forgotten. Likewise, the many nameless German wind tunnel technicians, the engineers who ran the tests, who collected the data, who documented everything. Their names aren't in any Boeing manual, in any Airbus document, but their work is in every airplane. And the R-234, the bomber that proved the concept of the jet bomber, only one surviving example, in a museum. Beautifully restored. But how many visitors understand its significance? It was the first. The proof that jet bombers work, that strategic jet aviation is possible. Without the R-234, the Allies might have dismissed jet bombers as too risky, too unproven, too experimental. But the R-234 proved it. Germany built one. Germany deployed it. It worked. So the Allies studied it, learned from it, and built better ones. The B-47 was faster, had greater range, carried more bombs. The B-52 was even better, bigger, more powerful, more durable, but both were based on the concept that the R-234 proved, and both used swept wings data that German wind tunnels provided. The technical lineage is fully documented. R-234, first operational jet bomber, July 1943. German swept wings research, 1935 to 1945. Schairer captures data, May 1945. Boeing builds Model 448 with swept wings, September 1945. B-47 flies, December 1947. B-47 production, 1950 to 1957, 744 built, B-52 flies, April 1952, B-52 production, 1952 to 1962, 742 built, B-52 still in service, 2025, planned to fly until 2050, almost a century. German concept, American production, global dominance. The irony is that Germany was never compensated for its own research. America built bombers with German data, sold them worldwide, made billions. Germany, rebuilt with Marshall Plan aid, later bought American aircraft. With swept wings, based on German research, paying for technology it had developed itself, the pattern repeats: torsion bar suspension, swept wings, ERA, Me-262 aerodynamics, always the same. German innovation, Allied capture, global dissemination. Germany pays to buy it back. But there's a difference. The swept wings technology was truly revolutionary. It changed aviation forever. Without it, modern jet aircraft would be impossible. Or at least much slower, much less efficient. The German researchers did the world a service, even if they were never acknowledged for it, even if they were never paid for it. The technology works. Lives were not lost because bombers became more efficient. On the contrary, civil aviation saved time, connected the world, enabled trade. That's perhaps the ultimate justification. The technology was good. It improved the world. Yes, it was used for bombers, but also for airliners, for cargo planes, for medical evacuations, for humanitarian missions. Swept wings are neutral. It depends on how they're used. But let's delve deeper into the operational details of the R-234. Because the story of its deployments reveals why the Allies were so keen to study it. December 1944, the Battle of the Bulge begins, Germany's last major offensive in the West. The R-234 conducts reconnaissance missions, photographs Allied positions, Tracks troop movements, and the Allies can't do a thing about it. British Spitfire B-47s, the RAF's fastest piston-engined fighters, had a top speed of 448 miles per hour. The R-234 could reach 457 miles per hour, only 9 miles per hour difference, but in practice it was more, because the R-234 could maintain its top speed at high altitude, where piston engines lost power. The jet engine worked better in thin air. That gave the R-234 an insurmountable advantage. Allied pilots reported frustration. They saw the R-234, tried to intercept it, but it was always too fast, too high, out of reach. Some R-234s were shot down, but not many. Most losses were on the ground. Allied bombers destroyed German airfields, fuel depots, production facilities. The R-234 couldn't be defeated in the AIR, so the Allies attacked it on the ground. March 1945. The R-234 is used as a bomber. Attacks on the Ludendorff Bridge at Remagen. The Allies had captured the bridge intact, a critical Rhine crossing. Germany desperately tried to destroy it. R-234 bombers flew mission after mission, dropping 1,000-pound bombs. From high altitude, at high speed, the bridge was damaged, but not destroyed, and bombing accuracy from high altitude and high speed was limited. The R-234 was fast, but precision bombing required slow, low approaches. That made it vulnerable. So R-234 pilots flew high and fast, survived, but often missed their targets. The technology was there. The tactics hadn't been developed yet. Nevertheless, Allied observers recognized the potential, a fast, high-flying bomber that couldn't be intercepted. If it were equipped with better bombing equipment, with radar targeting systems, with greater production, that would be game-changing. So they studied every captured R-234 intensely. After the war, captured R-234s were tested in America, in Britain. In the Soviet Union, every nation wanted to understand how it worked. The jet engines were disassembled, analyzed, reproduced. The aerodynamics were tested in wind tunnels, the materials were examined, every detail was documented. But as previously mentioned, the R-234 had straight wings, not swept. That was a limitation. German engineers knew this. They had designed variants with swept wings. The R-234C was supposed to have swept wings, or crescent wings. Jigs for the wings were already under construction, but the war ended before wings could be built. The technology was there, the time was not. So the Allies saw two things. First, a working jet bomber that proved the concept. Second, designs for swept wings variants that would have been even better. The combination was compelling. Jet bombers work. Swept wings improve them. So we build both. This brings us back to George Schairer and the B-47. When he saw the German wind tunnel data, he understood immediately. Jet bombers were the future. The R-234 Blitz had proven that. Swept wings were the key. German data had demonstrated this. Combine both, and you get superior performance. So he sent his famous telegram, "Stop the design, ADD swept wings, build the future." And Boeing did. The B-47 wasn't just an improved R-234 Blitz. It was a synthesis, jet engines from the concept proven by the R-234 Blitz. Swept wings from data provided by German wind tunnels, American production techniques, American materials, American design, but the foundation, German. Soviet development ran parallel, as mentioned, the Tu-16 and Tu-95. But there were others too. The Ilyushin Il-28 in 1948, a light jet bomber, straight wings, similar to the R-234 Blitz in concept, but with Soviet engines. Over 6,000 were produced, widely used in Warsaw Pact nations. The Il-28 proved that the Soviet Union had mastered the jet bomber concept, based on what the R-234 Blitz had shown. Then the Yakovlev Yak-28 in 1958, a supersonic bomber, swept wings, could reach Mach 1.7. This was far beyond the R-234 Blitz, but the line of development was clear. R-234 Blitz proved jet bombers. German swept wings data showed the way. Soviet engineers, including some German researchers, built increasingly advanced versions. Until they had supersonic bombers, the global impact is astounding. American bombers, B-47, B-52, B-1B, B-2, Soviet bombers, Il-28, Tu-16, Tu-22, Tu-95, Tu-160. British bombers, Canberra, Valiant, Vulcan, Victor, French bombers, Vautour, Mirage 4, all developed between 1947 and 1990. All jet bombers, most with swept wings. All influenced by what the R-234 Blitz proved and what German research data showed. The total economic impact is hard to calculate. But let's try. 744 B-47s built. Unit cost around $2 million, 1950s prices. Total cost, $1.5 billion. 742 B-52s built. Original unit cost around $8 million, 1950s prices. Total cost, $6 billion. Soviet Tu-16, over 1,500 built. Il-28, over 6,000 built. If we conservatively estimate $1 million cost per unit for Soviet bombers, probably too low, that's another $7.5 billion. Added together, over $15 billion just for bombers in 1950s to 1960s prices. Adjusted for inflation to 2025, that's over $150 billion. Just for the first generation of jet bombers, not including later variants, not including the B-1B, 100 built, unit cost $280 million, $28 billion. Not including the B-2, 21 built, unit cost $2.2 billion, $46 billion. Not including modern upgrades. The total investment in bombers based on concepts proven by the R-234 Blitz and German research provided easily exceeds $300 billion over 80 years. And that's just military. Civilian aviation, using the same swept-wing principles, is worth trillions. The impact of a single line of research is monumental, but who profited? Boeing, annual revenue over $66 billion. Lockheed Martin, over $65 billion. Northrop Grumman, over $36 billion. All American companies, all building aircraft with swept wings, all based on German research. Germany itself buys aircraft. Eurofighter Typhoon, partially built in Germany, uses a canard delta design with swept main wings. But Germany pays for it, for technology partly based on its own research. The irony is sharper when you look at the numbers. Germany paid over 20 billion euros for the Eurofighter program, for 143 aircraft. These aircraft use swept canards and swept delta main wings. The design is based on aerodynamics developed by German wind tunnels in the 1940s. So, Germany is paying 20 billion euros for aircraft that use principles it developed itself. The pattern repeats itself again and again, but there's a deeper question. Was this inevitable? Or could it have been different? Suppose Germany hadn't started the war. Suppose German researchers had published their discoveries in scientific journals, at international conferences. Would the world have adopted swept wings sooner? Would Germany have earned royalties? Perhaps, but maybe not. Scientific discoveries are often ignored until someone proves their practical application. Adolf Busemann presented swept wing theory in 1935. No one outside of Germany took it seriously. Until the war came. Until the need for high-speed aircraft became urgent. Then German researchers tested it, proved it, documented it. Would there have been as much research without the war? Unlikely. War accelerates technology development because resources are unlimited, Because failure is fatal, because innovation is essential for survival. German wind tunnel research from 1935 to 1945 was extensive because Germany was fighting for its survival. Peacetime research would have been slower, more limited, less comprehensive. So the story is complex. Yes. Allied nations captured German research data. Yes, they never paid royalties. Yes, they rarely acknowledged the German researchers. But without the war, the research might not have existed, or not in that depth. The technology that was captured was a product of the war, and the war was started by Germany. That doesn't justify everything. Individual researchers like Bussmann deserved recognition, payment, respect. They often didn't receive it. That's unjust. But the larger historical truth is that technology is treated differently in wartime. Capture, exploitation, proliferation, that's been true in every war. World War II was no exception. And the technology itself? It's neutral. Swept wings don't kill anyone. They're just aerodynamics. How they're used, that's the moral question. Bombers can drop nuclear weapons or humanitarian aid. Airliners can transport troops or tourists. The technology enables. People decide. 2025, the B-52 is being modernized, new Rolls-Royce F-130 engines, state-of-the-art avionics, improved communication systems. But the swept wings, unchanged, 35 degrees. The same design that George Schairer saw in a German laboratory in 1945, because the physics are perfect. There's no better configuration for that speed range. The Germans got it right 80 years ago, and it's still right. That's the ultimate compliment for German engineering. Not that the technology was copied, but that it's still optimal 80 years later, that modern engineers, with cutting-edge tools, supercomputer-aided fluid dynamics, and advanced materials, are still coming to the same conclusion. 35-degree swept wings. It's perfect. The Germans had figured it out, with 1940s wind tunnels, with slide rules, with paper and pencil. That's true engineering, not the most expensive tools, not the fastest computers, but the understanding of fundamental physics. German researchers understood aerodynamics on a deep level. They tested thoroughly, they documented meticulously, and they found the optimal solution, one that's still optimal 80 years later. These technical truths should be told, not to glorify the war, not to glorify Germany, but to acknowledge engineering excellence, to honor the researchers who made real discoveries, to understand the line of technological development. From 1935 to 2050, from Bussmann to the B-52 and beyond, if you appreciate this technical documentation, if you believe these stories need to be told, that inventors like Adolf Bussmann and the nameless German wind tunnel engineers should be recognized, consider using SuperThanks. It supports the research, the analysis of declassified documents, the tracking of these technical lineages across decades, because without this work, these stories disappear. The names are forgotten, the connections are lost, and that would be a loss for understanding how technology really works. The story of the R-234 and swept wings is more than aviation history. It's a lesson about how knowledge spreads, how war accelerates technology, how nations learn from each other, willingly or not, how inventors are often forgotten, while their inventions dominate the world. These are universal lessons, relevant to every technology, every era. And the future, the B-52 will fly until 2050, maybe longer. That's 98 years of service, almost a century. But eventually, it will be replaced. The B-21 Raider is in development, next-generation stealth bomber, flying wing design like the B-2. But look at the concept drawings, the leading edge, swept. Why? Because physics doesn't change. Swept wings reduce radar cross-section, improve high-speed performance. The Germans were right in 1945. And it will still be right in 2050. That's the ultimate legacy, not that technology was conquered, but that it was right. Fundamentally right, based on physics that doesn't change. German researchers discovered this physics, documented it, and now the world uses it forever. So, remember, the R-234, which proved the jet bomber concept, Adolf Busemann, who developed swept-wing theory, the German wind tunnel engineers who tested it, George Schairer, who recognized it, Boeing, who built it, the B-52, which will fly for 98 years, the swept wings that every modern aircraft uses, the technology lineage from 1935 to 2050 and beyond. Is this theft or technological evolution? Did America steal German research, or did it use captured data from a defeated nation? Was that just? Was it inevitable? Leave your opinion in the comments, discuss, debate, but above all, recognize the technical truth. R-234. First operational jet bomber, German swept wings research, optimal and unchanged 80 years later. B-52, still flying in 2025 with German designs from 1945. That's documented, that's verifiable. That's the story that should be told. The story of German engineering that changed global aviation forever.